slides. Share, share. Ah, good. Hello. Okay, let's see if it works. Welcome to Operational Security Capabilities. Rona is joining us remote. I'm, as you can see, is on site. So this is not well. I guess you've seen it many times this week, but look at this again. Housekeeping. Please use on-site tool if you want to join the queue, because it does help us chairs to control the queue. If everyone will be using the tool, doesn't matter if you are on-site or remote. If you join in from laptop, keep your audio and video off. And don't forget to leave the queue when done. What? Yeah, and speakers for those who are on site, I'll control the slides. We need meeting minutes taker. Any volunteers? Thank you very much. Really appreciate it. Okay, so we have 3 presentations today. First is working group item, indicators of compromise. And we have 2 drafts, which are individual ones. Since we met last time, about a year ago, we finally published operational security considerations for IPv6. What, it was 10 years? 12, okay. Is it a record? I don't know. Close, okay, close. So, and it got nice number, 9099. And we have another old draft in the RFC editor's queue about the filtering of IPv6 packet with extension headers. Hopefully it will be published soon as well. So the first presentation today should be indication of compromise. Okay, so stop slide share, share preloaded slides, and okay, let me share your presentation. Okay.
If I demask, thank you. Yep, hi everyone. So I'm here to present our draft on its case of compromise, the role and attack defense. It's on behalf of myself and the other authors, Kirsty, Ollie, and James. So next slide, please. So yeah, just to quickly run through the history of how we got here. So this originally came to Sec Dispatch at IETF114, brought it to Opsec following the recommended Sec Dispatch, made some updates. Since we presented it, Ollie presented it at IETF111 online. It was adopted by the working group earlier this year. And then the slide says no further reviews or comments, but actually Kathleen Moriarty kindly put a review on the list a couple of days ago. So there has been a further review, but I don't think there was anything in there that significantly changed the document with some helpful points. And yeah, I published the latest version earlier this month, which is I think the 6th version in total. So it's had a fair few rounds of feedback and review and change now. Next slide, please. So yeah, as a quick reminder of what the motivation was for the document. So I just wanted to document what is an operational security technique that's sort of out in the wild and widely used, and sort of just record the best practice. I don't think that's actually documented anywhere really. We also wanted to try and share it with the IETF. So I think it's not a topic that's necessarily got broad familiarity across the whole of the IETF. So we thought that would be a useful thing to do. We also wanted to just try and address that it's sometimes overlooked in protocol design. So a lot of protocols will make decisions that like basically make these IOCs, which I'll cover the definition again later, just make them harder to use. So we just wanted to make people aware. So if a protocol is coming out that's going to make them harder to use, that people know they're doing that and know what the trade-off is there. And lastly, I just wanted to bring some cyber defense expertise into the IETF. So all the authors work in cybersecurity, so want to try and bring that because I think there's not too many cybersecurity professionals across the IETF, possibly with the exception of this room, but wanted to sort of bring that in and thought this would be a good way to do it. Next slide, please. Yeah, this is the abstract. I'm not going to read it. You can all read it separately, read the draft if you haven't already. But sort of roughly just cover what indicators of compromise are, some ways you can use them, some ways they have been used, and roughly what their benefits are and what their limitations are. And as I said, some best practice. Next slide, please. Yep, so just to recover what IOCs are for those who haven't read the draft. So they're basically artifacts that you can use to sort of identify an attacker who's attacking your network, your computer. So these include things like their tactics, like how they act, the techniques they use, the tools they might use, or just like sort of IP addresses that they come from, and domain names associated with the attack. So some more examples there, including sort of hashes of malicious executables that they're using. And yeah, more of the tools. As we cover in the draft, like the range of IOCs that exist have different sort of benefits and difficulties. So like finding a domain name associated with an attack is quite easy, but it's also relatively easy for an attacker to change if you start blocking it. But if you put the effort in to diagnose exactly how they run their attacks and what tools they're using, that's much more fundamental to their MO. So it'd be much harder for them to change. But IOCs run that whole gamut. Next slide, please. Yep, so a quick outline of the draft. So we cover what the fundamentals of IOCs are, so what they are. So I just mentioned the pyramid of pain, which is that sort of scale I just discussed, and the life cycle, like how you use it all the way through from finding an IOC, like noticing it in a live attack, all the way through to deploying it out to the wider community so everyone can defend themselves, and through to like retiring it when it's no longer useful as attackers move on. We cover how to use them effectively, what some of the benefits are of using them, and a couple of case studies where in order to prevent sort of widespread attacks, IOCs have been sort of collected and shared and been put to good use to prevent attacks spreading. And then some of the limitations, like they're a relatively lightweight way of defending your network, so that comes with some trade-offs. And yeah, thinking about the different types of precision you get with different IOCs and the time and effort it takes to diagnose and use a given IOC. And then lastly, a brief bit on best practice, including sort of how you should share them amongst defenders. Next slide, please. Yeah, so this is a very quick presentation, just sort of remind everyone about the document. So we'd love further reviews and comments. I said we now had one from Kathleen, which we'll look to work into a future version, but any more comments and reviews really welcomed. And I suppose given we haven't had any major like comments or problems coming up on the mailing list or from any other quarter for a while, we want to know, like, do we think this is ready for working group last call? So we think it's pretty stable. We think it's in quite good shape. So yeah, that's it. Quite quick presentation. Any questions?
So I don't see anyone in the queue, but I'd like to ask people to tell who actually read the draft. I don't know how many. Do you? Oh, okay. Oh, sorry. I'm trying to do it on Meetup. I think I click on the wrong one. So I would like to get a volunteers to review it during the last call. Any volunteers to do this? Okay, we can ask on the list, but I really think we need to get some like review during the last call, and not just take a silence as an indicator of the draft the indicator of the draft should be progressed. But yeah, I will start the last call on the list after like next week, probably sometime. So yeah, I see some comments in the chat. Sorry. Yeah. Okay. Cool. Thank you very much.
Thank you. Yeah, and if anyone wants to talk about the draft, or if you haven't read it, please do seek me out. I'm very keen to talk about it. Thank you.
Okay. Share slides. So the next one should be source address validation. Igor, or who is presenting? Huh? We lost our presenters. Okay. I see. Just a second. Okay, so shall I share the slides, or you'd like to present yourself?
Jen, is Igor in the room?
No, Igor is not in the room.
Oh, that is surprising. I
So
didn't
do you
hear
like?
any. Yeah, I will
You do?
present it.
Okay. So would you like me to present this? Oh, here it is.
Oh,
Igor,
oh.
you like to present? Oh, good. We have a volunteer. Great. Okay, I'll preload the slides just on time.
Right.
Share. Okay, just a second. Okay, hold on. Why I am not? Yeah. Okay. Good. So tell me.
Okay, will do.
Voice control over the slides.
Yes, awesome. All right. So I'm Igor Lubashev, and I'm going to talk to you a little bit about our take on source address validation, and especially this is the work we're bringing here because it's basing on updating the work that's actually been published 2 years ago by this group. Next. All right. This problem should be quite familiar to everybody at IETF. We've been trying to solve it for at least 22 years. So how do we stop address spoofing, unauthorized packets being sent into the network? Since 2004, effectively the only technique that's been used is look at the BGP update messages, try to infer, look at your fib or rib, and try to infer something from that information what's valid. Feasible path was the best thing, which was not saying too much because it was proving quite useless in practice. It assumed absolutely no route filtering, so effectively very little traffic engineering. Well, that's not real world. So that's in 2020, 8704 was published, which was effectively an update on feasible path, which said, let's look at those BGP update messages a little bit closer and make a little bit more inferences and look at the origin AS number and therefore allow paths not just what you've seen on this interface in reverse, but also the paths that are advertised by the same origin AS than any of the paths that you've seen on this interface, which is better. Still has a number of issues. We'll see them. We'll look at them later. But it's better. It also has a little small paragraph saying that, oh, by the way, you can also look at raw information. But it's kind of an afterthought. It doesn't have any details, but it's an interesting idea. And this IETF, we have actually a working group. I mean, this problem is still not solved, SavNet. So more people are looking into it. Next. Next. Okay, good. Very simple example to show where 8704 still doesn't work. I mean, you have an AS1, which has a provider AS2. AS2 is multi-homed. It sends both ways. It's customer routes, but for whatever reasons, it only wants to send its own path to AS3. And now looking at if AS4 is trying to do some sort of address validation using 8704, it will only see path announced prefixes that where AS1 is the origin AS, it will not see AS2 as an origin AS, it will not consider its routes, even though it learns that there is a route like, from the peer. Okay, so 22 years in, why is this problem still so hard when so many people are working on it? My take is that it's basically because we're trying to infer some information about data plane forwarding from a signal that was never designed for it, which is reachability, BGP. So that signal just doesn't have enough information to do the right for the solution. So, and one of our ideas is that, well, not one of the ideas is that, hey, we have another sort of information that was also not designed for it, but things like RAW and ASPA, and actually it was recently suggested maybe also signed IAR data. How about we also mine that for source of useful information? Next. And just quickly, one more example that's important that we need to solve. I mean, this problem is kind of familiar to me because it's about some project that I was involved in. I immediately apologize for this slide. I took it from internal presentation. It has a lot more graphics than we usually used to at IETF. But effectively, it's CDN implementation where you have Anycast IP that CDN wants to serve content on. The Anycast home pub, I would call it that way, receives the request, decides that actually you want to serve it from another pub that, for whatever reasons, that's where content is, it's closer to the user, tunnels all the packets on that connection to the edge, and the edge returns the bulk of the media directly. So the only thing tunneled is headers and X. The heavy duty stuff goes direct. Nice layout. Next. So this is a picture of a generic direct server return. Doesn't have to be Anycast. You have a user in prefix 4, does a request, opens a connection to an address in prefix 3, which lands in a home pub. Home pub forwards it through tunneling to some edge pub in prefix 2. And that edge pub is supposed to return back, but it has to source the packets from prefix 3 so that the connection is complete on the client side, on the user side. So prefix 3 is only announced from Autonomous System 1, but that's the home. The edge AS2 does not announce it. It doesn't want to announce it. It doesn't want any direct traffic for the prefix. And the question is, will AS9, which is its provider, if it does source address validation, actually permit? DSR is a pretty useful use case. I mean, it's obviously CDN, but so is mobile roaming and some gaming, and it could be security products that are using it and so forth. Okay, next. And just some stats for fun. In 2015, we measured at several thousand of Akamai pubs around the world how many of them were doing some sort of effective SAV, source address validation, and we found about 15%. And just before coming to this meeting, I pulled some stats, and 2022, it's about 15%. So what's happening there? Economics have been suggested as a possibility, but actually for small networks, it is in their interest not to allow floods of spoof packets through their network. So it's not the full answer. It's possibly that it's just the techniques we have are ineffective, and they break too many things. And talking to operators, reducing support calls is one of the big incentives in deploying or not deploying things. Okay, next. So here is our proposal. We call it BARSEV, which is effectively using information from BGP, obviously, but also augmenting it with ASPA and RAW. And it's first of all, it's just an improvement on 8704 that Opsec published 2 years ago. It's effectively using existing data in BGP update messages better. 8704 was just looking at the origin AS number as a signal. BARSEV is looking at every single AS number in the AS path as a signal. We can look at it later a bit how it's doing it. And it's augmenting that information with info in ASPA and RAW. And one very important thing is deployability is key. Deployability is super important. And this algorithm requires no change on the wire in any of the protocols. So the very first network that adopts it will actually reap immediate benefits. And that's important. Next. All right, this is a slightly busy slide with a lot of circles, but its only purpose is to say that the algorithm works equally, exactly the same thing, both on customer interfaces and peer interfaces to build a SEV list. Next. High level of how the algorithm works. It's effectively a two-phase algorithm. Phase one, you want to discover the customer cone. Phase two, now that you have a set of AS numbers in your customer cone, you want to discover prefixes that they own. How do you discover a customer cone? You start with a single AS number that you know, which is the AS number of the other side of your interface, or your customer or your lateral peer. And then you can look at ASPA and see what networks define this AS number to be their provider. So that's basically that's a customer relationship. And then you also look at AS path of all BGP messages, no matter where they're received, no matter what interface. It could be your peer-to-peer interface, it could be coming from transit, doesn't matter. And you see what AS path, look at all the AS paths and see what is the previous AS number to this AS number is in any path. And the previous one will be its customer. So you discover a few AS numbers, and then you repeat the process for the newly discovered numbers, and you stop when there are no more new AS numbers to discover. Once you're done, you have a set of your customer cone. When you have a customer cone, you look at raw information and find all the raw entries that list the customer. And you look at all the BGP entries, BGP update messages, and just like 8704, find where an AS number in your customer cone is the origin AS number, and you add those prefixes to your SEV list. And you merge everything together, and that's your SEV list for the interface. Next. All right, next. Super busy slide. Don't read it, but just the point is that it has a lot of different cases. It has it has route filtering in it. It has prefixes that are published in RAW, prefixes that are not. It has autonomous systems that have ASPA. That has autonomous systems that don't have ASPA. What we're going to do is just give an overview how the algorithm again will work, which is next. So first, you discover the customer cone. You're looking at the AS4 customer interface with AS3. You look at AS3, there is nothing in ASPA that defines AS3 as a provider, but there is a bunch of AS paths in BGP update messages, and you find the previous AS numbers. So you discovered a few new autonomous system numbers. Iteration 2, for all the new ones, okay, well, now we discovered that AS1 and AS2 are listed as providers for a few autonomous systems. You add them to the list. You look at BGP. Well, AS6 is listed again. Great. Well, AS7, now you discovered AS7. One more path. You discovered nothing new. Fine, you have your customer cone. Next. Now you look at for each AS number in your customer cone. You look up row. You find prefixes. You look at all your RIB effectively for every interface, and you discover a few more prefixes where this autonomous system numbers are in the origin place, and you got your SEV list. Next. Now we can go back to the example we've seen before. I mean, it's kind of a very trivial example. So 8704 wouldn't discover prefix 2, but BarSev will easily do that. It will build a customer cone. It will trivially find that AS2 is in its customer cone. Even if there was like some intermediate system between AS2 and AS4, it would just find AS2 by following the rules. And once it knows that AS2 in its customer cone, it will use a BGP update message from its peer to see that, oh, prefix 2 is originated by AS2, so add it to the SAV list. Next. CDN example. Our CDN owns both autonomous systems 1 and 2, and it owns prefixes 1, 2, and 3. So what it needs to do is it needs to publish row that says that autonomous system 2 can advertise effectively prefixes 2 and 3. Now, it never means to advertise prefix 3. It never will. But by the virtue of it being in row, BarSev will pick it up now that autonomous system 9 knows that AS2 is its customer because it sees prefix 2. And from row, it will pick up prefix 3 at also belonging to prefix 2, and therefore direct server return will work fine because prefix 3 is known to be in the sublist for that interface. Next. Now, looking at having ASPA will actually help you find route leaks. Obviously, that's kind of one of its main purposes. And it also can be used, and also would be used by BarSev algorithm by effectively checking the path. So in this example, you have AS2, which has leaked a route from its peer. So the route to the red one, the route for prefix 5 has been leaked to AS9. But when AS4 is doing BarSev, and first thing it will do is to check ASPA. So when it's seeing AS2, it sees that, when it sees a prefix that has AS8, and AS2 is after it in the path, but AS8 is found in ASPA, but AS2 is not its provider. So first of all, of course, this route shouldn't have ever been even accepted for forwarding, but it will also not be used. So this AS2 will never be added as so AS8 will never be added as a customer of AS2. And So therefore, AS8 and therefore AS5 will not be in the customer cone. So AS5 is not going to be allowed in the sub list on AS4 to AS2 interface. That said, in the draft, we say that, hey, if that prefix actually made it to AS4 for some reason, you could still infer that AS9, well, AS9 is a provider for AS2, so AS2 is a customer of AS9. We obviously will ignore AS2 to AS8, but we can, if for whatever reason we need to, it's still in, we could use information saying that AS5 is a customer of AS8. Now, in our search, it was never needed. In a more complex network, it could have been something that could have been used. Okay, next. And okay, that's basically that's the highlight of the proposal.
Okay, questions? Silence. Okay.
Thank you.
Thank you, Igor. Cool. And the next presentation is Eric. Okay, let me get the slides. Okay, share.
Okay, thank you. My name is Eric, and together with Justin, who is in the room as well, and Benoit, who is on vacation somewhere, I don't know, in a beach or in a winery, we wrote this small draft. This is most probably the smallest draft I have ever written, so we'll be pretty quick. Next. So where it coming from? So if you attended Justin's presentation this morning at V6Ops, we basically send packets over the internet to do some measurement. In this case, it was for V6 extension headers, but it does not matter which kind of measurement you want to do. Basically, when you do a measurement over the internet, you inject synthetic traffic. The synthetic traffic is sometimes weird because you want to test the reaction of the global internet to some strange packets. In this case, extension headers, for instance, but could be anything. Sending strange packet to the network may trigger security alert. Sometimes unusual traffic pattern, different size, or even crash some system. Of course, it's not the intent of the researcher sending those weird packets, those probes, to crash the systems or trigger alerts, but it's a side effect. So the thing, if we want to do a research of an internet in a fair way, I think the bare minimum is to advertise in the probe or something who is sending those weird packets, basically claiming it's not an attack, and please contact me if you have an issue with this. Next. Again, the idea is pretty simple, 5-page internet draft, right? The goal is to have a URI describing the experiment with contact details and some more description. So the URI could be an URL pointing to some specific text, and we basically there follow RSC 9116, which is the FUDIL security. So basically that's a text file. Human readable, could be multiple language with some keywords telling phone numbers, language, description, and so on. Could also be, and that's what we used in the James experiment, an URI which is a mail to, or if you dare, a URI which is the phone number. Of course, if you do it over the internet, you may receive call at 2 a.m., which is maybe not what you want to do, but who knows. Basically, that's URI. So next. There are two ways of putting this URI. One is in-band. So you put this URI in the packet itself. So for instance, ICMP, you can put the URI obviously into the payload. UDP, same thing. Even TCP SYN packets can have data. It's typically not used by application, but it's a valid packet. Now, if you play with extension headers, typically you can create an extra option, unrecognized, but you can mark it as skip or ignore, right? So you can get it through, and it's visible in the packet. Of course, if you're doing some ESP experiment, please use ESP null, because if you put it in the ESP payload, obviously it's unreadable. Next. So how do you put it? What we do, if you do the URI in the data payload, and you are allowed by your experiment to put it directly after the, let's say, UDP or TCP header, you do it, put it there, and you terminate by a null byte, just to be clear. Now, if your experiment requires you to put some data into the payload or into the extension headers, you put the same URI, but to be sure that to start, where is the start and the end, you put a null byte before and a null byte after. Next. If you don't do this, and again, it's no rocket science, if you are for some reason unable to put this URI in the packet itself, you need to use an out of band. You rely either on reverse DNS, and you use a well-known URI, right? Simply, if it's reverse DNS makes example.net, you use the .wellknown / probing.txt. This requires an IANA section for this, which is in the draft. Or if you cannot do reverse DNS for whatever reason, run a web server on your source address, obviously, with the same URI there, BI, right? The same path. Everyone will notice that HTTPS to an IPv6 address is not common, right? You will not get real certificate for it, but you can still run HTTPS on the top of it, right? It will be a self-sign, obviously. And I think in the next slide is the last one. So we use, Justin and the students and myself, this technique based on previous experience. Suggestions were already received, I think, by Fernando and a few others on the list. Comments are welcome. It's a very, very simple thing, but I think it still deserves publication as a RFC, the most simple one. Again, so questions and maybe call for adoption. And I hope it was useful. And it looks like there are questions.
Yeah, I see people in the queue. So, Ron. Ron, can you hear us?
Can you hear me now?
Yes.
Okay. An unexpected consequence of this draft might be that network operators filter packets that contain the URI. It's of no benefit to them to participate in your experiment, and there is risk involved. That may bias the results of the experiment that you're performing. Have you thought about that?
No, I was not thinking about this, but it's for sure that, yeah, that's a, to come back on the first presentation, that's a kind of indicator for compromise somehow. So it could be detected as an attack or even could be proved as a dropping packets or improving the quality of service for these packets to say, hey, this ISP is better than others. Who knows? Yeah, that's a fair statement. It deserves at least to say it in a paragraph or in a section in the draft. Thank you, Ron.
Okay. Annalena?
Yes, hi, Nalini Elkins. Eric, well, this is a potentially a good idea. What would stop me from putting in the name and phone number of, for example, my ex-husband with whom I'm having a custody battle?
Yeah, I don't know what your ex-husband has done, right? So I understood that the reason why I put another joke on it. I hope at least. Yeah, of course, it's goodwill. I mean, doing this is a goodwill thing. reacting on it is a goodwill thing. Basically, when twice in my lifetime I generated those kind of packets, right? And I think as a goodwill researcher, you want to do something good for the network, and you do this. Like every mechanism can be bypassed, right? So you can put example.com or google.com, as Google is there, as the URI, or the email address of Jen, right? That's for sure.
Yeah, let's put Jen's address.
Yeah.
So you said you did this for the V6 Ops James thing?
Correct.
Which one of them did you do, and did anybody ever contact you?
Nobody has contacted us, and we were using the mail to URI.
In band or out of band?
In band. Not only because it's short, right?
Okay. Nalini, are you in the queue intentionally or you just, I can remove you just. Okay. Fernanda?
I won't necessarily say that I regularly send these packets, but let's say that I know people that regularly send this kind of packets. And, in theory, it seems to be a good idea. The challenge that I find is that quite often it would affect the proof packets that you'd be sending. Like, for example, just to pick on one specific example, but that's just because I heard it during the presentation. If you include data in a scene packet, there are systems that might process the packet differently as they do without the data in the sync packet itself. What I know that people do when they want to be, let's say, friendly about the experiments they do is, if they are, going to poll the network from, some address, is, on the one hand, configure the reverse DNS mappings for the address that you use for the proofs, and then host a website on that address such that you can explain in that website, what it is that you're doing, what you're doing it for, and so on. On the one hand, because probably, the people that detect these things, they test, they go directly there just to check. And the second, because in that way, you're not affecting the proof packets themselves.
That's a fair point for the in-band use of it. And the out-of-band, it's either you run it on the root, the root of the web server, or use the .well-known probing.txt, right?
Yeah.
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 We agree. Thank you.
Robert?
Hi, Robert Story, ISI. I had two comments. On the in-band, have you thought about maybe putting some kind of identifier in the packet for people to, for example, maybe something like Wireshark or TCP dump to be able to recognize what's in the packet and show it? Because a lot of people, they look at a raw packet dump, they're not going to go to the effort. They see some ASCII, they may or may not delve further. But if Wireshark or something automatically call it out,
like a magic bytes or something like that.
Right,
yeah.
exactly.
6 bytes that are
Right.
Okay.
And speaking to the earlier point where people could be filtering, that could be considered a feature. Most people that are doing research projects allow people to opt out, and having the identifier, they'll be able to recognize those packets. And there was a recent discussion on NANOG about this very thing by somebody very irate at getting some packets. So I think that could be considered a feature.
Yeah, I do agree. Thank you for the suggestion.
Yeah, I'll hijack myself to the queue. No hats on. I'm just thinking that running web server or something on the source address of the probe probably wouldn't be always feasible if you have a lot of vantage points, like a RIPE Atlas, right? You're like, no way you're gonna do it on your like every single
Specifically when you
device.
have dynamic source address.
Yeah,
right?
yeah. So I don't think it's like in general like feasible approach, because I think most of the measurements are actually done from a lot of different vantage points. It's not like you run a measurement from one single thing.
And the other point on this, if you're using V6, you typically have a /64, and you can get 2 to the power 64. Right now, we can cheat as well on the reverse DNS on this, but what cheat?
Igor, are you in the queue?
So I think it's a good idea it's an interesting, at least, idea to put up flag, something that says I'm not part of any production flow. I'm a test experiment, but just to echo that, any identifier that names an individual or a project, because if you do that, I'm expecting that I'll have to create a identifier address validation draft, because again, same problems.
Yeah, but keep it. My point is keep it cool and simple, right? That's a goodwill thing, better than nothing, basically.
Thank you. Yeah, Warren Kumari again. Yeah, I think we should be careful that we don't end up with the perfect being the enemy of the good, right? Like at the moment, there's no useful attribution, even if it's not perfect, even if it doesn't work under all conditions, even if some people don't want to use it because it adds data, at least it's something that people can use if it works for them. So
Yeah.
I see no downside.
Thank you.
So I assume you'd like adoption call, right, on the draft?
Is
Okay,
there
yeah. Okay, we'll run it on the list. We'll ask for adoption on the list after this IETF. So thank you, Eric. So that's all on the agenda. Any other business suggestions? Warren.
Warren will turn the mic around. Actually, yeah, I'll just stand here. So, hey all, I am the AD for Opsec, and I've been doing the AD thing for quite a while now. My term is up in March. I will probably run again, but I'd really, really, really like some people to run against me. And so if anybody's even potentially interested in serving as Ops AD, please come along and talk to me. And I'm more than happy to explain to you what the role is actually like, what the time investment is, why you might want to do it. It is actually kind of fun. So just, please consider putting your name in for Ops AD when the nomination's open.
Thank you. No, you have to try harder, Warren. Okay, thank you, everyone. So see you in the next IETF, hopefully. Please consider writing interesting drafts and comment on existing ones. Thank you very much. Have a nice day. Yeah, I feel like it's